So the meter, a couple of things about the meter. You're going to take this meter apart. There's two screws right here. Take the sensor off the meter before you take it apart. And look right here, you'll see all kinds of little scratches on this meter. That's because somebody removed these bolts without removing the sensor, and it scores, right? Now, it hasn't damaged it yet, but over time, that's going to break this meter, okay? The other thing is, if you think you have a meter problem, and you think it's stuck in there, and you want to confirm that electrically everything is working, if you unconnect that cable, and you plug it in and unplug it, plug it in and unplug it, that's going to force an output. In other words, if you go up to your screens, you should see your flow rate or your incrementers going up. However, that is not the best way to do it. The best way is to pull this off, take something metal, and just pass it by that sensor. That's going to give you the same thing, produces pulses, plus you're not worrying about bending one of these pins by taking that connector off and on so much. Okay? You bend that pin and it breaks off, and you're replacing it. Right? To clean the meter, to take it apart, you're taking it apart, it's probably because it's stuck. It's probably got some bad catalyst in it that cured. When you take this apart, take all the screws out, leave the middle of all four sets in. Back them out a couple of turns, and then, because this won't be loose like this because of the cured catalyst in there, then hang on to it from the top side here and use a rubber hammer and bang on these screws until it pops off the bottom. It's kind of a reverse wheel puller, right? What you don't want to do is get in there with a screwdriver and start prying to get it apart, because if you do that, you run the risk of shattering the pins that are on the gears. Let's take this apart. All right, so once you get it apart, basically these gears should spin freely just like this. If they don't, you're going to pull everything apart, you're going to clean everything. What you're not going to do is you're not going to take a wire brush, you're not going to take it to a bucket to go and try and clean it all. You can put them in on that, what do they call it, the vibrating bats?
Ultrasonic.
Ultrasonic, yeah. You can put it in there, but don't take a wire brush and try and clean it. When you put it all back together, first of all, the gear should spin freely on that pin, right? And when everything's put back together, these two gears should also spin freely like this, okay? This O-ring right here, this is PTFE, Teflon. Teflon cold flows. What that means is when you put energy on it, it stretches. And when you take that energy off, it stays stretched, okay? So I have a great deal of success reusing these O-rings in low pressure systems, not so much in high pressure systems. If you look in the manual, they say every time you take this apart, you should replace that O-ring. Like I said, I've had a great deal of success reusing this O-ring, and over time, taking it apart and putting it back together, it does weaken this, and you should replace it. All right, talked about adding a solvent meter. This is what the solvent meter looks like. As you can see, there's way more teeth in that solvent meter than in the G3000. It's also got a different angle of cone, and it's got a bearing as opposed to a pin and bushing. So this one should spin much freer. It's designed to handle the light viscosity of solvent. The solvent will slip past these gears, and you'll get an inaccurate reading with this meter. This is only meant for materials with viscosity. The other thing about this meter is there's shims on both sides of the gears. When you take this apart, you will not see that shim. You take the gears out, you will lose the shim. You put it back together, you won't even know you lost it. When you tighten these down, it'll tighten over these gears, and the gears will let it go. Correct? If you ever take it apart, just realize there's shims on both sides, and they're super thin and super easy to miss. Pass these guys around. Questions about the gear meters? All right, I'm going to move on to color change valves, and I'm going to bring in two color change stacks. One is low pressure, the other is a high pressure. You're going to see some similarity in these valves. They physically look different, but the design is pretty much the same. I'm going to start with the low pressure valve. One of the nice things about the low pressure valve is up in top here, there's a little pin that pops out. This valve is selected, that pin will pop, so you have a visual that it's out. The reason we can do that with the color change valves, not the dosing valves, is color change valves are air operated open and spring close. You don't need an air to close it like we do on a dosing valve. The dosing uses air, open air closed, so they're high speed or faster acting. Color change valves are open and they stay open until you select a new recipe, and then they close. So we don't need that air input. All right, on each valve, there's going to be a little hole right here. That's a weak one. When you start seeing material coming out of that hole, that means that that U-cup is starting to fail. And that's your visual that I should get in here and rebuild that valve. Now, I say that's your visual indicator. The truth of the matter is, you just said these valves open and they stay open until you're done and then they close. Not like a dosing valve where it's opening and closing a couple hundred times an hour, right? It's open all day long or until you select another recipe and then it closes. Service on color change valves are pretty minimal. Anyways, just like the Pro XP gun, remember this morning I said when you pull that nozzle off, you got to pull that trigger and get that needle off the seat. Same thing here. All we're going to do is I'm going to take this cap, get that spring out of the pad, and pull that piston back. I don't have pliers on me. You want to pull that back. That removes the needle from the seat. And now I can take my wrench and I can unscrew my valve. Okay, so there's my valve. We made these to be basically modular, which means if I got to service this valve, I hopefully have another valve from the wrench that I can just toss in here, and then I can do a better repair on this at leisure and get this guy back up. One thing I didn't mention is obviously that it's under pressure, so if you're going to service it, you have to shut the system down. And that's not just the one paint source, that's every paint source in this color change stack. Once I remove that, we're now moving to the whole manifold. So if you're going to service this, you got to be shut down. Okay. There is a seat. I'm going to pass this around. There is a seat down inside here. You can take an Allen wrench and remove the seat to replace it. But I want you to look down in there and you can see right here, I've got this plug there. That plug is there because this is non-circulating. If I was on a search system, I'd have to remove that plug. And I'd have line returning from here back to the supply for full circulation. But if you look down inside here, you're going to notice that the plug interferes with the removal of that steam. So you have to back that plug off to remove that steam. All right. I'm going to separate the piston from the needle assembly. Separate this. Residual thread sealer in here, that's why it's all right. right, so I took this apart. There was some blue thread still in here. That's why I kind of came apart. We'll talk more about that in a minute. You've got spacer slash seal, and then you've got this little bushing that came out, or bearing. This bearing sits down in the cavity, so this has some support as it's riding or opening and closing. Down inside is the U-cup. This is the component that started to fail, and you start seeing some drip out of that loop. To get that guy out, you're just going to take an Allen wrench or a small screwdriver. You're just going to go in from the back side. You're just going to get the edge of that and push it right out the top. When you do that, you just want to make sure that you're taking caution that you're not doing this, right? Because every time you do that, if you scratch the inside of this, you can find some steel and you might not feel it. All right, so when you rebuild this, you're going to get the kit and it's going to come in. This tool is used to help you get this U-cup down inside this cavity. You can drop it down in there, and then you can take a bigger Allen wrench and put it around and push it. But this tool makes it much, much easier. You load the U-cup in this part. You're going to use that plunger to push it out. So basically, you're going to take it. It's going to get you into the position you need it. And then you're just going to push it down in until it pushes it all the way down inside there. Bearing that in there. That's steel. This back together, I am again going to use some medium strength thread seal on here. It's not as critical on the color change valve as it's going to be on the dosing valve, and I'll talk about that in a bit. But it's best that you put medium strength thread seal at that connection. Obviously, there's torque specs on all of this, and I don't remember, I don't memorize them, so I'd have to pump the manual. You have to make sure you pay attention to the torque specs on these. And then you're gonna use a little bit of lubricant here to push this guy up through. You're pushing it from this side. Take caution that you're not running these threads in this edge through that U-cup to damage it. You just want to push it through there gently. And then reconnect your piston keeper. This one is a bolt. Right, at this point, once the valve is rebuilt, you can screw it back into the manifold and then put your cap back on. Again, that's critical because you don't want to put the cap on it now because that's going to force the piston way out, and that's going to push that needle into the seat and cause wear on that seat when you reinstall it. Okay, so that's the low pressure color change valve. We're going to take a look at the high pressure color change valve. And again, it looks different, but it's going to have similar. It's just physically looks different. Again, the first thing I'm going to do is I'm going to remove that piston and get that spring. Spring out of there, grab that piston now, pull it back, get that needle off the seat. have this guy apart. All right, the other one came apart, but that's okay. So from here, there is no difference from this guy. You're gonna take it apart, you're gonna have a piston, you're gonna have that bearing in there, you're gonna have a U-cup. The only difference is the needle is a little bit larger on the high pressure compared to the low pressure. Other than that, these valves are the same. When we get into the fluid manifold, dosing valves are the same as this guy. There's no difference. So I'm not going to tear this down because you're not going to see anything. Okay? There are two different styles of this manifold. This is the newest one. It came out a couple of years ago. It's just like the low pressure color change stack. Look down in there, you're going to see that that seat is screwed in. I'll pull this first. Running into the same problem. I gotta get these guys out. All right, so there's your seat removed. If you look down inside there, you're gonna notice there's a ring that sits beneath this. It generally stays inside here. So if you're replacing this, you get the O-ring. Make sure that that other O-ring is out and remove the new one in. Because if you double the ring, it's not going to stay. Yes. Well, the other thing I was talking about was this maneuver is all one piece. If you've got a newer one, there may be like a two-piece system here. There's what I call on it. It's basically bolted to this. So this piece is removable from the main manifold on the older side. And I might have a seat that's reversible in it. This one is just screwed in it. It's not reversible. By the way, on the meter, I forgot to mention it is pinned, so you can't put this cover on backwards. It's on an unefficient. Any questions so far on either meter or the color change? All right, I'm going to start on the manifold. I have two manifolds here. The difference between the two of them. Basically, this is the 2KS manifold. You've got the dosing valves on top, and you've got air and solvent purging valves down to the side. Okay. This one here is for the 2KE, but it's for a pump-based unit. It doesn't have this sequential integrator chamber. So for those of you who have 2KE meter bases, it's this manifold with this body here. Okay. I'm not going to take this one apart because we're not going to learn anything new on this that we're not going to learn on this one. There's a couple of check valves in here, the same check valves that are in here. Okay. The dosing valves are separate blocks that are detached from this. This one, the dosing valves are right on it. The dosing valves are separated from here, but it's no different from this valve and that seat that we have passing around right now. It's identical. Okay. We're going to remove this guy. All right. I'm going to start with the integration chamber. This guy right here is the thing you're going to have to maintenance the most. This is the one where you're going to pull this cover off. service, and I heard a couple of you guys say, when I pull this off, I really have to pull hard because it's so full of stuff in here, right? So for those guys who have to pull this apart, there's some people that don't ever pull this apart because the paint and the solvent they're using are super compatible. And it flushes really clean. What we have to do install after a day of production, I have to pull this off and look at it. If it's really dirty, we may have to change flushing sequences. We may have to make some adjustments on the solvents we're using. I will tell you that most of the times the here is because of the solvent choice of solvent that we're using to flush these systems. In other words, every paint has a solvent that's best for flushing. And just about every solvent that's best for flushing is not the cheapest. It's usually kind of expensive. So people go to a lower grade solvent. That lower grade solvent does a great job of flushing this. That's why you have maybe continuous this apart. The other thing is if you're using reclaimed solvent, it typically ends up with moisture content and decreases the effectiveness of the solvents. And reclaimed solvents would also allow for clear to here. So basically, you're just going to pull this apart, make sure it's clean. If it's not, you can pull this apart even further. You can pull this completely out. Cap off the top. Take something soft like a toothbrush and push anything that's plugging these holes back inside, and then take a bottle brush through the center to clean it out. What we don't want is we don't want you to get in here with a little thumb drill and start pulling those holes. The reason we don't is because if you get in there and you start making the hole sizes different, in other words, you get in there and over drill one of these holes, you're not going to get good distribution of catalyst throughout that integrator. Whatever hole is larger is going to get larger amounts of catalyst coming out. So you get uneven distribution of catalyst. It might not be detrimental to most paints, but some paints may be affected. All right. The other thing that you can do is on the bottom of this, you can remove this plug. And access to the housing that holds this chamber. Now, one of these is a cap and the other is a plug. Pull this one out, this end one. Then that housing should fall out the bottom. This is the housing that the spindle screws into. This end, the reason we have that pin I just pulled out, is that pin runs right through here, and that makes sure that you line this up so this is lined up with the canvas expense, this base opening is lined up with the base. You can't pull everything down through the bottom. All right. Like I said, the valves now are all the same. We've already done one, but I am going to pull one off so we can get down into the check is. And basically what I'm going to do is I'm going to pull this cap up. Because again, I want to remove this valve, but I don't want to run that needle into that sleeve. So best practice is get that spring out of there. In addition to that, if I try to take this valve off, these 2 bolts, I'll be working against this spring. So we'll be pushing the valve. I'm trying to remove it. I'll show you more what I mean in a minute. All right. I'm going to remove this whole housing, and that that needle, this spring is still in place, is pushing that needle into the seat. So as you can see these bolts, that spring is pushing this valve back. So I'm working against spring pressure the whole time I'm trying to remove this valve. I am going to have every one of these run done. All right, so the reason I'm pulling this blue valve off is to show you the seat that sits beneath it. Carbide seat, and it can be flipped, reversed, and there's an O-ring on each side. So there's an O-ring down here, and there's an O-ring here. The reason I needed to pull that off is because I needed to get access to these portions. This block. And this valve was blocking the holes. If you look at the new Pro-Mix V, we changed the design of this so this block isn't impeding this. So now you can take that block apart without having to remove the valve. One of these, let's do this check. But blocks are marked A and B. Try and keep them on the same side when you build them. All right, so there is your check. Pass this around as well, and I've got some brand new ones in here too. Got a kit, you can kind of see what you get. You buy the kit to rebuild it, the checks, and you get all the things. And the checks should come completely built, just like those out. You had it built up, pass it around. You'll see that there's a ball, a seat, a spring, and a O-ring very high. If you look at that O-ring, that's a crushed O-ring. In other words, when you rebuild it, that check in there, you tighten it down, it's going to crush that steel. If you pull that steel off to get in there and clean that check out, you're never going to get it back together. That steel is damaged beyond reusing it again. So if you pull that out, you can clean it. Don't take it apart unless you have new ones. Make sense? All right. As that's being passed around, I've got just a couple more things I want to do with you. And that is the sample valve and the isolation valve. Put a snap ring down inside here that you remove, and then you can pull this isolation valve. The isolation valve simply has two rings that comes up. On it. This will be a low wear, low impact. Remember that new seals do come with the rebuild kit, so this isolation valve is used for meter calibrations. When you're doing a calibration, you want to make sure that you screw this isolation valve in. And basically, it's blocking the passage. So material, when you're getting a sample through the sample valve, can't leak up into the integrator. Right? It's just ensuring that everything's coming out of this valve into your beaker and nothing's going up in here so you can also dispense. That's it. When you're all done, make sure you open it back up. You know, we can call they say, hey, I just did a meter calibration and now my system is not working. You say, okay, do you open the isolation valve? No. Saying a lot of times when people call in, you guys heard them talking about this. 60% of the time, it's the simplest thing that causes the biggest problems, right? Is it plugged in? Is it turned on? Is it open? Because it's true, right? All right. The last thing I want to talk about before I start rebuilding it is this sample valve. The sample valve itself, if you pull off, There is the O-ring. It's a base O-ring, so there's no dead space in here. You're gonna back this T-handle off, open it up, and then to open the sample valve. And the sample valve is going to be a seat and a ball and a plunger. And basically all you're doing is by pushing this guy in, you're pushing that plunger into the ball, forcing it into the seat. When you open it, that material can pass through there. So when you do this and you clean it all out, you put it back together, make sure this is back on. Then reassemble this. Then once it's reassembled, you close this. You don't want to have this closed and reassembled because if you overtake this, you're going to force that valve into that chloride seat and it's going to crack that seat. So best practice is make sure that's turned completely out. This is the component next to the integrator chamber that you're going to probably service the most. You have taken your samples from here and not here, because it's hard to get this guy flushed up. Again, if you get a chance to go over and look at the Pro Mix feed, actually have change this to design to be able to work it. Because the common problem with that is getting plugged up, servicing it, and then rebuilding it wrong and crushing that. Back together, double check my seat's in there, my O-ring is still in there, rings feet in there. We install this valve. I have this valve reinstalled. Then I can tighten this cap. On the low pressure valve, this cap gets tightened all the way down. Okay? Then it's rebuilt. High pressure. That manifold still up there somewhere. So, put this back together, no not. Everything back. In. That's when you're going to go ahead and tighten these back up. The valve right here. There's no valve up there too. That's okay. And put this back in. If you took it out from the bottom, again, what you're going to have to do is you're going to have to make sure that this lines up with where the pin is going to come through. If you don't get it perfectly lined up and you don't have access to turning it like this, there is an Allen wrench, a hole on the bottom. You can put an Allen wrench in there and turn that body until you get it lined up.
You don't have that up there, but it's two things.
change valve once this is screwed all the way in. Again, then we would put this cap back on. Remember, I said when you rebuild these valves, you put straight red sealer in this connection. The reason is because we don't want this valve turned all the way down. When we put this cap back on, we're going to turn it until it snugs down, and then we're going to turn it back a turn and a half. And when I turn it back 1.5 turns, don't let this threaded connection break. Dispense valve left. Put the check back in. Place, and I'm just going to put it back to the side. And next year, Rick, we should have a whole new manifold to work on with the
Right.
12XB.
So we're gonna have to.
We'll have to have another class. All right. Back in. O-ring is in place. When you put this back on, make sure that you have the outlet in the right position. In other words, if you put this back on here, now you can get your fluid connection back on the back side. So make sure it's accessible to where your fluid connection is. Everyone keeps telling me that, and every time I service one of these, it's perfect. I look pretty pro, don't I? Nothing's torqued down. There's no paint on it. Lucky guy. All right. Once the valve's back in, then I can put my cap back on. And again, the factory setting for this is 3 in, 1.5 turns back. If you look in the manual, it will say you can back this out to 3 turns and actually back it out a little bit more than that. You can do that if you have a really thick material and you want to put up in a needle seat area to get better flow through there. If you've got a really thin material, you can tighten it up, okay? Usually no more than 1/2 turn. You might do that for a really thin wide ratio material where you want that valve to open and close really fast. Okay? If you open this more than 5 turns, you might be able to do it, but what you don't want to do is you don't want to expose this flow rate. If you expose this flow rate, then you're going to get slow action operation of this valve. Okay? The last thing is our cover back on. And this one doesn't have it, but there should also be a mixer coming out here. That's that insert is I here part. There's an outlet there that you can get it down to the needle. That is the last component I had. Manifold. And I didn't pour any of these valves apart, but they are identical to the valves we put apart on the colors. In fact, we have a lot of customers that are pressure, but they order a system of high pressure counter tank stack, just so they have commonality of everything else, and they don't have two of those. All right, question? Okay. Just like in the Pro XP that I mentioned this morning, in that session, we have a lot of videos on them and done. You have to do repair on this 4 months from now, and you want to refresh, just go to yeah.
What would you recommend for maintenance intervals? I know every plant's different, every paint's different. I'm talking dispense valves and blocks.
Yeah, so it's really hard for me to say every 30 days or every 60 days. Typically, the customers are doing an annual rebuild with this. You're not going to have to get in there and rebuild this guy. I say the best thing to do is, if you can, daily, just walk over and look to make sure you don't have anything dripping out of these little holes. And then that's it. This guy, you might have to start looking at this thing every week, and if it's clean every time you take it apart, maybe monthly. If it's dirty, then maybe you're just gonna have to take it apart every week. So I hate to answer that way, but every system's gonna be a little bit.
Yeah, we got one plant probably hadn't been done in 8 years.
Yeah.
So
And that plant maybe has really good flush sequences or using the installment. The need for them to do anything is not good.
Right.
And I've had customers that pull this apart every day.
We're gonna talk.